Welcome to IGBits. We train, you learn. Today, we shall see the concept of sample space in probability. I would like to take a few seconds to let you know that we are now on YouTube channel. Please do visit us at IGBits. We are continuously uploading our sessions to make sure available for you all to access at your own time. One request that I would like to convey through this channel, please do help extend your support to your friend circle to share our knowledge base to help them to build their knowledge. Thank you for so far whatever the help that you've been doing. Continuously, do same helping hand to us to build a knowledge base to help everyone. Thank you all. Sample space in probability. We know the probability definition. Probability definition is the ratio of number of favorable outcomes by total number of outcomes. Do you see total number of outcomes, whatever the experiment that you will be doing, right? That is known as a sample space for us. For instance, let's say you have a coin, right? The coin have two sides. So how do you name them sides? One is head, other one is like a tail, right? Suppose you are tossing the coin, flipping the coin. Then what do you see? Your probability of getting either a head or a tail would be your interest. So if you look at this experimental space, when you toss the coin, let's say you got a head, one instance. The other instance would be like a tail. So the head and the tail are the two things that are going to come as an outcome in your experiment. So getting head, probability of getting head, probability of getting tail. The getting head and tail, that the head and tail is known as a sample points. These sample points are part of your sample space. So sample space has two sample points in this instance. Now, how do you calculate a probability? So in the total outcomes in a sample space, when you consider a single coil tossing, we have two outcomes. That maximum possible outcomes are head and tail. Right? When you flip the head, when you flip the coin, either you are going to get head or tail. So these are mutually exclusive and equally likely. What that means is when you are getting head, you are not going to get a tail. When you are going to get a tail, you are not going to get a head. That's why mutually exclusive. Only one of the two is going to happen, not both. Right. Second thing is like equally likely, meaning probability of getting head or tail have a equal chance. Let's say for instance, from the math point of view, if you try to plug in the values into this formula, for first case, probability of getting head, the probability of getting head is how much? Getting head probability is like 1, right? 1 possibility, and the favorable possibilities basically, favorable outcome is 1, and the number of outcomes are 2 within the sample space. So 1 by 2 would be your probability of getting head or probability of getting tail. So since you are getting the equal value of probability for getting head and tail, that's why we can call it as a equally likely. But the mutual exclusive means the case that we are discussing, right? If you are going to get head at the same time, you are not going to get the tail simultaneously, right? Probably in the next experiment, you may get this head and a tail differentiation, but together will not happen in the single coin. That's it. So I'm recapping. For a single coin toss, we have two sample points, head and tail. So these are the possible outcomes and hence we are considering our sample space is nothing but heads and tails. That's it. Second thing, probability of getting head, probability of getting tail is 1 by 2 based out of this formula. What it means? Probability of getting that event is number of favorable outcomes divided by total number of possible outcomes. So this case is precisely we're talking about a mutually exclusive and equal likely. So equal likely in the sense, when you tossing the coin, what you are saying is like the sample space has a head and tail, right? So if you are trying to calculate the probability for getting head is total possible outcomes are 2, getting head is only 1, right? So the favorable outcome is 1. So that's why probability of getting head or getting tail, the value is 1 by 2. So we have a 50% chance of getting head, 50% chance of getting tail, and hence this is known as equally likely outcome. Okay, that's the concept. So let's look at the few contexts and then figure that out, like sample space for that context. For instance, you are taking the context called as sports. What mostly we will see in sports, winning the game, losing the game, or draw the game. Right? These are the things that you may see. So now the question is, what is the sample space for this context? So what we are seeing is like event outcomes. Winning is an outcome, losing is an outcome, drawing is an outcome, and hence our sample space is win, lose, draw for this context. Do you understand? So these are the maximum possible events in this context, and hence the sample space is win, lose, and draw. That is how you can see what is meant by sample space. Each element in this set is known as a sample point. So sample points consist of a sample space. So next context, medical testing. When you go for a medical test, undergone medical test, what would be the outputs that the medical report says, whether you are going to get a positive result or a negative result. So a sample space for the medical test is a sample point positive, sample point negative. So sample space is consist of positive and a negative. Do you see how you are actually identifying like a sample points and then contributing towards to the sample space identification? Let's look at weather forecasting context. What are the sample points you can see in weather forecasting? Different weather conditions. What are those weather conditions? It may be sunny, it may be rainy, it may be cloudy, it may be snowing, right? These are the typical sample points that you can see, and hence our sample space for this weather forecasting case is sunny, rainy, cloudy, snowy. Let's say suppose you are doing like a customer survey response. Means like you are actually making some questions, but the answer to the question would be a simple for the customer point of view, right? The possible answer responses for the a survey question would be like a strongly agree, you agree, you are kind of a neutral, disagree, or strongly disagree. So these are known as a sample points in your context, and hence your sample space would be you know uh, strongly agree, agree, neutral, disagree, strongly disagree. These are the sample points which consist of your sample space in this survey response context. So I think this is useful for us to understand like how to arrive a construct a sample space from the context. Let's say you have a two coins and then you are trying to create a sample space for tossing two coins simultaneously. Now the question is, two coins are independent coins, right? And then the possibilities for getting, you know, head and tails is kind of a combination. Do you see this picture here? Uh, the probability of getting head and tail and head, and tail and tail. So there is a four combinational outcomes is what you are going to get using two coins. So 2 multiplied by 2 is nothing but a 4. But how do we really understand, right? So without coin, are you creating a concept of the two coin flipping part? So we have three methods to arrive the sample space. One is a just a list which we talk about, like head and tail head, tail tail. Second things, you can construct a simple table and then representing a table. So the coin one is on the row, coin two on the column. What you see is like you how many possible outcome that you are going to get for each coin, head and tail. So you represent the states, head and tail. What you do now, you can build a table now. So what I'm saying is this is head and head. The combination here is head and head. Now here head and tail. So your set is head comma tail. Look at here now. This is a tail and this one head. Right. Now look at here, tail and a tail. This way now these four are the outcomes when we are actually using two coins flipping cases. So these are called a sample space for your tossing two coins case. Okay. So now we have seen list and the table, but there is a one more option called a tree diagram, which is more useful, for calculating probability even. Let's look at how that arrives. Let's say suppose you are here and then you are actually flipping a coin. So what you are going to get first, for one coin you will be getting like a either head or tail. Let's look at this way. So what is the probability of getting head? Half, because for one coin we say for getting head is like a half. For the tail is also you are getting, tail is like an half for the one coin. So for each possibility now these two are actual fixed states. Now you do a flip of second coin. After you getting head, what is the possibility of getting head and tail for the second coin? This is a similar possibility. So you are going to get here head and tail. Let's say the first coin you are getting tail. You fix the position of tail, then you see the possibility of getting other two outcomes using the second coin. So would be H and T, right? So if you look at every coin have the two possibilities, but after head you may get like a two possibilities. After tail you may get a two possibilities, right? When you're using like a two coin concept. What you see now is, look at these options. Let me so if you look at now here, head one combination, head to tail one combination, tail and head one combination, and a tail and tail another combination. That is how you look at. So let me note down now. So you are saying this one, head and head. So this is one set. We can also see this one. So head and tail. This is one more sample point. You look at this now, tail and head. So tail and head. This is one more combination. So you look at the other one, tail and tail. So by using tree diagram, you can clearly state it out, like how many paths that you have and then how many sample points that you can create. All the sample point is nothing but your sample space, right? So if you consider a probability, so for one coin that we know the number of possible outcomes are two and the number of favorable outcomes each one. So 1 by 2 is your If you look at here also, this is also same, right? For getting this second coin, getting head is like 1, getting tail is like half and half. This is also similar, half and half, isn't it? So if somebody asking probability of getting head and head, if somebody says like, what do you mean? Half multiplied by half is nothing but your probability. So half multiplied by half equal to how much? 1 by 4. So probability of getting head and head would be 1 by 4. That is how you have to calculate. Now let's look at a simple math for getting probability value for a favorable event. Let's say you are trying to when you are flipping a two coins, like a tossing a two coins, you are trying to achieve head and head. The coin one should get a head, and in coin two also you should get head. So what is the probability of getting head and head would be your question. Let's say now we know the constructed table with all the possible outcomes. So what we have, head and tail and head, and tail and tail. So we have 4 possible outcomes. From the you know uh, probability of getting the event that you look for is number of favorable outcomes divided by total number of possible outcomes. Total number of possible outcomes is your sample space. Your sample space in this case is like 4. You agree? Because 1, right? So 1, 2, 3, 4, right? So total you have 4. And hence 4 is the total possible outcomes. So what about favorable outcome? In our case, you are trying to ask only one, which is head and head. You are trying to ask this case. So getting head and head would be only one possibility. Agree? And hence your favorable outcome is 1, and then your total is 4. 1 by 4 would be your probability of getting head and head. Agree? 1 by 4. So if you ideally speaking, right, you have a two coins. For getting head in one coin, how much value? For probability of getting head in using one toss, which is 1 by 2. Similarly, you can look at a probability of getting second coin with head 1 by 2. So 1 by 2 multiply 1 by 2 is 1 by 4. These are the two independent coins, and then you can calculate a two independent probabilities and multiply them to get a probability of combined probability of getting two heads when using two coins. So from this table also, T diagram, if you look at the math fun will come. Let me pick the different color for our, or maybe you can take white color. Okay. So let's say you are here and then you are flipping a coin. This is the first coin, this is the second coin. Think about that way. Right. So what you would do now, uh, what we say like this is head, this is a tail. This probability is head, this probability is tail, this probability of head, this probability of tail. But so we will say like this, getting head is half, getting tail is also half. This also have, this also have, this also have, this also have. It's a simple thing, right? Now you look at a different path. Whatever the event that you are looking for, that would be your answer. Let's say you are considering head and head case, this case. So for getting head and head, what is probability? F multiplied by F, which is nothing but your 1 by 4. Look at this case now. Head and tail. This case is head and tail. So what is the probability? F multiplied by F. So 1 by 4. So similarly, you can calculate other two too. So and hence doing independently and then multiply them, or combinedly you create a sample space and calculate them. Both way you should get the same answer. No confusion. Sample space for spinning wheel. We know this, the game, spinning wheel game. Uh, the wheel gonna spin, and then indicator is pointing to the outcome. When the wheel is going to stop, we see like what is the number that is going to likely to come towards to the the indicator point. So if you are going to get the number, then you will be win, otherwise you are going to lose. That sort of the outcome of this game. So the fun part is now we have to figure that out, like a probability of getting the number that you choose from the total event. So what is the first step that we are going to look at? This one, creating a sample space. So you have to look at like how many distinct numbers that we have in the wheel. You see there is a fun, there is not like a sequence number here. 1 1 1, there are the three instances, three occurrences of 1 is there on the wheel. So 1 is a one event, right? So that's why my sample space is 1. Similarly, I have a 2, but there is a 2 instance of 2, and then I have 3, 2 instance of 2, 3, and then 5 is only 1. So 5 is 1. So my sample space is 1, 2, 3, 4. These are the sample points. Always you are going to get either 1, 2, 3, 4 in this spinning wheel game, right? But probability of getting 1 would be your favorable outcome. There is a 3 possibilities for getting 1 because we have 3 instances. How many total, you know, total outcomes we have here in this case? 1, 2, 3, 4, 5, 6, 7, 8. So total 8 possible outcomes in this spinning, within which you have a 1, 2, 3, 4, 5 are the sample points. So getting 1 from this spinning wheel would be 3 out of 8. Agree? Total is 8, but your probability of getting 1 we likely to be have 3 chances out of 8. So your probability is nothing but number of favorable outcomes divided by total number of outcomes, so possible outcomes. So if you can give a number assigning for this event, how do you represent now? This is nothing but 3 divided by 8. So probability of getting 1 would be 3 favorable outcomes divided by total number of possible outcomes, 3 by 8, right? So similarly, you can calculate probability of getting 2, right? So a favorable outcome, this is a favorable outcomes, and this is a total, and hence, so 2 by 8 would be your probability of getting 2. Similarly, 2 by 8 would be your probability of getting 3. Here you have only 1 5, and hence 1 by 8 would be your probability of getting 5 from your experiment. Do you see? So irrespective of the context, you try to figure out all the sample points, occurrences of the sample points as a favorable events for that sample point, and then look at a total number of outcomes. So if you know the sample space and then sample points, and then you should be good to calculate a probability for getting that favorable outcome. Now let's look at a rolling dice case, and then understanding the sample points and sample space, and then possible events and favorable events, right? When you look at a rolling dice case, like you are taking a single die which is of a six-sided. So the numbers, if you look at, I think sample points are 1, 2, 3, 4, 5, 6. So these each one is called as a sample points. So we have a 6 possible sample points, and hence our sample space is consist of 1, 2, 3, 4, 5, 6 if you can give a number to it, right? Our probability of getting event is number of favorable outcomes divided by total number of outcomes, possible outcomes. So let's say for instance, you are just looking at a odd and even, getting odd number, getting even number. Getting odd number is how many? 1, 3 and 5 are the odd numbers. So we have a 3 favorable outcomes for getting odd number. Similarly, if you look at a even, 2, 4, 6 are the even numbers. Out of 6 possible outcomes, there are the 3 even numbers, and hence, so even numbers are 3. The occurrence of even is 3 favorable outcomes, and hence our sample points for getting even is this much. Our sample points for getting odd is this much. So the total sample space is this much. So for calculating a probability in this case, very straightforward. Agree? So our as per this formula, what we are saying is like total possible outcomes are 6 for both cases, right? But for getting an odd number, the favorable outcomes are 3. In this case also, the probable outcome is 3, and hence the answer is 1 by 2. Okay, for the dice case, this is also called as a likely case, right? Equally likely case for getting odd, getting even from the six-sided die. Do you get it? Very good. Let's say you have a 3 coins and then you're trying to tossing 3 coins and then looking at like all the sample points from these experiments and then to construct a sample space, right? When you have a coin, we are saying that we have a 2 possibilities, head and tail, but you have a now 3 coins. So the possible sample points are a tail, 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 a tail, tail, head, a tail, head, tail, or tail, head, 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 tail, tail, head, tail, head, 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 tail, head, head, head. How many? 1, 2, 3, 4, 5, 6, 7, 8. So when you are using 3 coins and then getting favorable outcomes of each is like a 2, and hence 2 power 3 is nothing but 8. That is how you will get a total number of outcomes. Clear? So 2 power 3 and hence 8. So 8 total sample points that you are going to get using 3 coins. Let's construct using a T diagram. These sample points. So for this is a coin 1. What is the possibility of getting head and tail? The outcomes are 2 outcomes, right? This is T, this is H, right? We know probability is like FF for the individual case. Now look at, you fix this position T, then you flip the coin, second coin. Then you may have like 2 chances. One is like second coin getting head, getting tail are the 2 cases for when you are considering the second coin when for the T position. Similarly, you look at, let's say suppose you get a head in the first coin. Even then, if you try to actually toss the second coin, what you are going to get, like you may get a tail or head. It's a possibilities. Like after second coin flipping is done, now you look at the probability of getting the combination using the third coin. This is again a T H T H T H T H. You understand this construction, how it is going to happen, right? So what I'm saying, for this first coin you have 2 possibilities, and then you fix with this position, and if you flip the coin twice, then what is getting? 2 T and H are the 2 outcomes, possible outcomes that you are going to get with a second coin. So what you're saying, like fixing first coin at a T, you may get 2 chances. If you are fixing H as a first coin, that you may get other 2 chances. That's why your combination constructed this way. Now you fix these positions and try to do the third coin combination. For each position, you may get a 2 possible outcomes like a tail and head, tail and head, tail and head, tail and head. This is how you can construct a T diagram. Now you trace the path. T is one sample point. TH is another sample point. THT is a one sample point. THH is a one more sample point, right? HTT one sample point. HTH is one sample point. HHT is one sample point. HHH are the other sample point. That's why you are going to get a sample points with a combination of 3 points. Let me write down since we said loudly. So if you look at this case, this trace, what is my sample points? T, T, T. So T, T, T are my sample points. If you look at this one, T, T and H. So T, T, H. What about in this case? I have T, H, right? T, H and T. Look at this sample point. At T, H. Up to this point. Now I have to look at this one. So T, H, T. H or T, H. Okay. Now look at, let me choose a different color. If you look at this path now, so H, T and T, isn't it? So H, T, T. Look at this one now, H, T, H. Look at now this case, right? This one, and then go this path. H, H, T, H, H and T. So last one is directly we are going this direction. So H, H and H. Now see, so T, 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 H, and then look at now T, H, T, T, H, 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 T, T, and then H, T, H, 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 T, and H, H, H. So a table construction or the T construction is going to give you total sample space. This is what you can call it as a sample space. So the T diagram is going to help you to construct a sample space so that you will easily identify the sample points. You can consider rolling 2 dice and then construct a sample point. This is one more interesting story. So when we roll it, right, there is a combination that you get at 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, right? Are the 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, or 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. These are the total outcomes that you are going to get when you use it 2 dice of 6-sided each, right? So total outcomes are 36. 6 multiplied by 6 is nothing but a 36. So you are going to get a 36 outcomes in this experiment. Total outcomes is 36. How do you get it? 6 multiplied by 6 is nothing but your 36. Right. So that's a story. Your sample space is going to grow when you're using like a more number of dice. But combinationally, you have to understand how this is going to happen. Let's say if I am trying to get a probability value for getting 4 4. Okay. So for getting 4 4, what is the probability when you are using like a rolling 2 dice case? So 4 4, how many occurrences that you are going to get when you in this combination? You look at a 4 of horizontally and 4 is vertically. The coincident point is called 4 4, which is nothing but your favorable outcome. How many favorable outcomes of getting 4 4 is only one. Total outcomes are how much? 36. So 1 by 36 would be your probability value. Is it? So 1 by 36 would be your probability value for getting 4 4. Okay. We can do this in the different math also. Let's say you have only two coins. Getting 4, getting 4 when you rolling one die is 1 by 6, your combination. For getting second dice, for getting 4, what is the probability? 1 by 6. 1 by 6 multiplied by 1 by 6 is nothing but 1 by 36. So either you do like independently and multiply, or you try to create a construct a sample space for the with all possible outcomes for that rolling two dice case, then your answer remains same, right? The approach is up to you, but you can easily arrive the answer. So if you look at a little closer, let's suppose like you have a two dice of six-sided, and then total possible outcomes are six, right? So I am going to conduct a independent test. So the first case is what I'm trying to do, probability of getting 4 and the probability of getting 4 is what I'm trying to do in this case. Probability of getting 4 here is what we have a sample point, only one sample point here. This is a sample space, right? My sample space is having like a 6, my favorable event is 1. So probability of getting 4 is how much? Favorable outcomes 1 divided by total number of outcomes 6. So 1 by 6. If you look at a second die, right? Second die. So what is my probability of getting 4? This is also similar. So this is 1, but my sample space is 6, right? And hence 1 by 6, right? If we put together dice 1 and dice 2, d1 and a d2, then getting 4, how do you calculate? 1 by 6, this probability is 1 by 6 multiplied by this probability, and hence 1 by 36. So for getting 4 4, so my probability is 1 by 36 when we are actually using two dice. Are you clear? Well, good job. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Thank you everyone. Thanks for joining. We shall continue our learning in next class. Stay tuned to next session. See you again.